Good evening, team. I wish to welcome you to the new course that is Computer Networks. So, Computer Networks will run a span of 7 days, of which the first 5 days we are going to break down what Computer Networks is all about. In it, we are going to do the the simple summary of what the computer basically networking is. What does it mean by computer network? How do certain computers or devices that are connected get to share information from one location to other location? What methods do they use to get to share information from one location to the other location? And what are some of the rules they have to follow for this information to be able to be located from one location to the end? And at the end of the day, we want to see how do these computers get to understand each other. E.g., I'm about to send some information, it's on WhatsApp. So I type something, I'm sending to someone. How does this computer get to know to whom specifically this information has to go to, and how is this information going to go through? Because sometimes you come to find that it could be wirelessly done. So I could be looking at the desktop. This is the desktop of my computer. You find that there are a lot of cores that are moving, and people are talking. A lot of information is flowing from different locations. People are browsing on the internet, and they could be using the same channel, just free air, to communicate, and the information is able to be spread. So basically, computer networks is something very important. It's not specifically because you're an IT specialist, you are a network or a data network expert, or whatever category you belong to. This one is a mandate to know because it actually puts you in a position to understand what is going on. Some people want to have a network at home where they could be able to watch maybe Netflix movies and that. You need to basic to understand what is really going on. You need to understand the security that you're getting to go into. We are in a world at this point in time where we are people want to buy things online. You want to buy be it on eBay, you want to buy on AliExpress, Amazon, different websites, different sites. And people, when they do these purchases, nowadays people are meant to enter their bank details to make a bank transfer, mobile details. So sometimes coming to understand networks, how this information is going to flow, it's quite important because you're going to know the means and ways how you're going to protect yourself so that this information does not get to be taken up by the unwanted people, so-called hackers, who are going to steal off some of the information that is being sent. Because if you're saying this information is being sent through the air from one person to the other, there could be somewhere someone who could have the device or a method of tapping this information and channel it to their own location and be able to view and listen to such type of information. So in the world where we are, everything that we are using, we have smartwatches which are connected, we have smartphones that we are using with to do information, you're typing assignments, and most of the things we're doing them from there. We have smart cars, we have smart TVs, we have basically a lot is smart, and you can't do without this internet because everything is about being connected. You just see how you get to feel when you're not connected to the internet. You feel like everything is shuttered down. You want to buy a bundle here and there. But what really is that bundle? What are you really doing to get access to that internet? And what is it giving access, or what access is it giving you to have? And how are you able to go on the internet and browse different things? So this is an in-depth computer networking. So we want to move slowly from the slow information or basic information until we expand it from there. So there is no expertise needed. We just want basic information. From the basic information, then we build step by step till we make a tower. So please let's start together. Find time to go through, do a replay of the information that you feel you haven't caught up with. We keep moving bit by bit till we get to move to where we want to go. So we want to go direct into the PowerPoint presentation. So we've made this PowerPoint presentation for networks so that we can get to understand it from the underneath. and be able to capture it through uh, from the word go. Okay, so I do once more welcome you to SmartNet Edu Center. SmartNet Edu Center is an online educator. It's been partnered up with different universities that have come together and are offering online education in different languages. There's Spanish, we have Portuguese, we have Arabic, there's English, and Chinese, and two other different languages. So what happens is the people the language that you're okay with, you're going to register up that language, and once you register up that language, we are going to place you in a group where you can get to be taught in that different language by different instructors. Personally, the one who is conducting this, I'm Max Omwape, and we're going to share this information so that at the end of the day, you get to follow through. I'll be corrected for further videos. Should this one be too fast, too slow, kindly correct me so that we get to move together. So straight away, uh, computer networks. So under computer networks, the introduction segment of it is we are going to look at these two cardinal things, because whenever we talk of computer network, there is data and there's networking. So what do I mean by data? Data basically, we have to be exchanging this information. So there's data sharing, data exchange. Whenever you are connected to the net, all you do is just data sharing. You are getting information from someone, you are sending information to someone. That is simply that. There is nothing else other than that. That data can be in a different form or function and format that can be sent from one location to the other location, or can be accessed by you from one location to the other. And wherever you're accessing this information, be it on Google, www.google or Yahoo, wherever you search that information, all you are doing is there's a certain computer outside there that is giving you this information that you want. So you are not just jumping in a free space or the free ocean. No, whenever you search for anything, whatever you type, whatever you look for, there's a certain facility that is giving you this information. You're on Facebook, there's a certain facility that is responding to you, giving you this information. So that is what we call data communication. It's a sharing of information from one place to another, and we can call this to be local. And at the end of the day, it can also be remote. So remote communication, we have different facets that are allowing that, and direct or local communication is what we do one-on-one when we are chatting with friends and doing one or two gossips. So we come to computer network. A network basically is a set of computers that are connected together with the purpose of sharing resources. Resources just put data. So we are categorizing data into resources. So different computers can be connected together and be able to share. Why we are saying, because when we say I have a network of friends, a network should not just be individuals whom you don't communicate to. It should be a person that you can talk to, they can respond to, because that's when communication would have been established. There has to be an exchange of information. So whenever you talk of computer network, you can never be on a network when your computer is just one. You have just one computer that is seated alone. No, it can never be a network. It can never be a network when there are just two computers connected. There is no share of information. No. The only time it will say connected is when you are able to send information and you are able to receive, or vice versa. So a computer network will only happen when there is a connection with a basic view or purpose to share information. And now we come to see these resources can be a computer, can be a printer, can be a file, can be different things that can be connected to the internet. So now we want to look at this data. What are the things that are going to enable communication for this computer network? What are the two things, or the most, we call them the five important facets. So there are five important facets that are supposed to be the prerequisites or the must have. Whenever we talk of a computer network sharing information, there has to be this. This is a must have. One of them is the message. There has to be information that is made possible for communication sake. So there has to be this type of information that we want to send. Is it a picture? Is it a number? Is it an audio? Is it a video? Something has to be in the middle, which is going to be sent or shared. There has to be the sender. So one device among the connected computers or devices needs to be identified as the sender. Then the other, so the sender device, now we can talk of workstation, telephone, video cameras, all these. There has to be something has to be a sender of a signal or information to the main, to the other segment. Then there has to be what we call a receiver. So a receiver is a device that is going to receive that message that is being uh, maybe the basic of the conversation that is needs to be shared. So there has to be that receiver. Then we come to talk of a transmission medium. So there has to be a transmission medium. It's a path through that information is going to move and reach the other segment. So, e.g., information is moving. There are two major methods you come to see on the transmission medium. We have the wired one, we have the wireless one. So these mediums, they are the ones that are going to carry this information. Information is going to throw through this until it reaches the other end. Then the last part we have is the protocol. Now, a protocol is a set of rules. It's a constitution that governs how computers get to communicate. Now, this constitution is the one that eliminates the issue of hackers or anything else that we put that might get access to information that is not needed. Because you come and see that five different rules that each computer has to follow in the network to talk to communicate. And part of these protocols will do one or two things to this message that is going. So this message is specifically sent to one person who is going to understand it. And part of it, you are going to see there will be kind of encapsulation, the timing, amount of data sending, data timing, different. You know, there has to be a message that has to come from the end. Once the end user gets the message, there is this automatic feedback that has to come, and all those until the whole complete set is done. So there are different protocols that we have to follow, or the rules that we have to follow for successful information flow between different computers. Now, we want to talk of this data flow, how this data can flow through these mediums, because we talked of the wireless and the wired medium. Now, we have three ways in which data gets to flow. So there is what we call the simplex, half duplex, and the full duplex. So we can just call it a duplex because that's a full duplex. So half of a duplex and the simplex. So there is a quarter duplex if you want, or simplex, half duplex, full duplex. So in a simplex, it's a unidirection. And in this unidirection, one is only the receiver, the other one is the sender. What do I mean? When you're typing on the keyboard, what you type on the keyboard is the sender, and the computer is the receiver. Same applies to the monitor. I'm not talking of your touch screen because the touch screen of a phone, it's both a receiver and a sender. I'm not talking about that. Just look at your computer monitor for a non-touch computer. What happens is the computer sends information. It's a picture, whatever you're watching here, it sends to your screen. Your screen can only receive the signal to give you a display. That's all. It can't send back the display back to the computer for anything. No, it only shows. It's like just a bulb. We just turn on the switch, the bulb goes. It can't go vice versa. The bulb can't send a signal, then the switch goes on or something happens. No, it can't do that. The information flows from the switch turn on button direct to the light, and the light goes on. So that's how basically the monitor gets to work. And the same applies to the keyboard. So the keyboard we just input. Once we enter that information, it's one-way direction information. So there is a simplex. So there are some categories of this computer in the network where communication will happen where one individual is his position is just the sender. The other position is just the receiver. And information can only move in this direction from the sender to the receiver. It will never be vice versa. Now we come to the half duplex. So the half duplex, it is both ends can be the receiver and can also be the sender, but it can only happen at one moment. It can't happen at the same time. So one can only send, the other one can receive. At the second time, the same one which was receiving can now be sending, and this other one will be receiving. But it can't happen at the same time. A simple example is those who use radio message. You go on, say, Oscar, yeah, yeah, you talk something like that. I heard it somewhere. So you get a radio message and you talk on the radio message. Hey, you got this and this and this and this. You come to hear that you have to press a button, then you talk. Once you talk, you are not going to hear anything that is coming from this station. You just talk in it, and that you let go. That's the only time now you can get a feedback. So you have to talk. When you're done, you let go, and the other person will talk and receive. So you can receive, but it can't happen at the same time. Information cannot flow at the same time. So that is the other way data flows. Or in this kind of communication, how computers are going to be connected. This is another way how data is going to flow. Then we have a last one, which is a full duplex. So the full duplex, it's bi-direction. I can talk, you can talk, you can hear, I can talk. I can even interrupt you. You're talking. Hey, just hold on. What did you say? There? You can go ahead like that. This is what happens, what we are using in cellular phone. So you're able to call to talk to someone. Hello, how are you? And the conversation goes on. They can make cuts in the conversation, and you can slice in the information that is needed, and that is what we call the full duplex. So the full duplex is the type of communication that we're using in cellular. The half duplex is the type of communication we're using in TikTok. Those I don't know, those small radios and all these radio messages. Then away from that, we have what we call the simplex. So the simplex information moves in one direction, and one is identified as the receiver, the other one is identified as the sender. So that's the explanation for those the simplex, the half duplex, and the duplex. Now we come to the different types of computer networks. Because what we say is a computer network is a different computers that are connected together. Now, one other thing that you have to understand is there are what we call nodes. A node is any device that is connected within a network. So any device that is within the network where information has to flow through it is what we call a node. A cable is not going to be a node. It has to be a device that will do one or two things to the information, either relay or receive this information or act on it. So that is what we are calling a node. So you keep in mind that a node can be an end node. End nodes are computers and other things, printers and such. Then we have what we call intermediate nodes. Intermediate nodes are switches, routers, those that are going to receive the information and be able to relay it in another direction. Basically, they can't do a basic manipulation of information, or they can't be the sender or the ends. They are just intermediates. So those are end nodes. So they are nodes. That's how we identify them on that. So a network is a set of devices which are connected by communication links. And the communication links we mentioned, they are cables and wireless. A node can be a computer, a printer, other devices capable of sending or receiving data generated by other nodes on the network. So this is simple. It can be two computers that are connected together. So both two will be nodes. One computer to the other computer, one phone to the other, one computer to the phone. You connect a USB, your phone to the other one. That's a node. So there is data share there. And at the end of the day, uh, both will be exchanging and receiving information. So now we want to see the different types of categories of these computer networks. So there's what we call a LAN, there's what we call a MAN, there's what we call a WAN, there's what we call a PAN. LAN is for a local area network. There's MAN, there's wide area network. That's a Manchester. Sometimes we call it a Manchester area network. The PAN, that's a personal area network. So let's look at them individually. We see what each stands for. So the local area network. So we see in the local area network, this is where we come to see. I'll give a good example of let's say a company. So in this company, I'll just jump to the picture, then I can use this picture to explain. So in this company, we see they receive internet from a network provider, be it Zamtel, MTN, um, Microlink, whatsoever company supplying internet. So once they receive that internet, they jump it into a switch. So they jump that network into a switch. And once that network is in the switch, they are able to connect different, their computers, laptops, and other different offices can connect in one environment. So this network is coming through the router, then they are able to share all the network in different devices. This is what we call a local area network. Now, what you come to see the advantages of such having a local area network is so different nodes can share resources. Different nodes, different computers can share information. So what I want, if I want to move maybe from this laptop, which is on top here, I can print direct to the printer that is connected on the network and information will flow like that. I can also get to have direct internet to my computer here. I can send things direct from my computer to the other. I can even do file sharing. Instead of using a USB cable or a flash to send data from this computer to the other computer, all I can do is once I'm on this local area network, I can be able to share direct data. I can share from one location to the other within a same company, within the same location, same hospital, same school. So this is what we call a local area network. It's just one company, one environment that is having within the same geographical location. I can just call it like a small location where everything is running together. You can have this land and the internet will get to be distributed as such. So that is what we see as a LAN. So you have a group of computers which are going to be each connected, maybe in a small building or small office, each is going to be connected. Now, and so it will allow different computers to be connected. You see there are what we call the twisted pair of cables. The twisted pair of cable is the RJ45 and UTP cables. So there are those UTP cable used, and they have the hubs or the sockets, which is the RJ45, which we get to use and we get to connect, and information we get to flow. We can also get to use wirelessly, and you find that we can use the small things like a hub, network adapters, and Ethernet cables to get to run this information. And data can be transferred at a quicker pace because the area is just small, which is manageable. And we've seen that we can even provide security because whoever comes to connect in the network, we can insert passwords, we can do some limitation, or it can be under one management, so we can easily control. It's quite difficult for someone to come and hack into the LAN because it's kind of controlled and coordinated through one specific individual location, so to say. So someone needs to come and link into it for him to do one or two fake connections. So that is the LAN, the local area network. So this is what we talked about. So the Manchester or metropolitan, this metropolitan area network, you come to see that it covers a city. So I'll look, let me go direct to the picture, then we look at it. So we talked of one company, one school that is covered in that local area network. Now, when you talk of a Manchester or metropolitan area network, you come to see that they are different. You combine different, maybe a mine, a company, a school, and that this can be big, even as big as for the country, the whole country. There are some networks, if you see in some places, in some countries and continents, they have put some network whereby anyone who's on the street can access to the internet. They will set up this man, and it will be large enough for a big geographical area. You'll find that some school in another city as is connected, another company, another town, another location, different buildings, they are all connected. And what you can notice is there is for these devices to connect, they're using routers, they're using switches. Who come and talk about what are these switches, routers, hubs. So they're using these and access points to get to change and bridges to get to transfer information from one location to the other, transmitting from wireless signals to electrical signals in cables and wireless. So there's an exchange. So there's that data transfer and information can be shared amongst the buildings that are there. So that is a metropolitan network. And we come to see that it covers a large geographical area. and you come to see them government agents, they get to use that and are connected to each other through a telephone exchange line and as the higher range than the local area network. We saw a local area network was smaller, but this one is quite large. So now we come to the wide area network, the one. So the one is is actually large. A wide area network, it spans a large geographical area to the extent of a country or a continent. So it can connect Africa, Asia, different segments. That is what we call a wide area network. So what can it be a composite of? We can see that there are small lands that are connected, small lands, small companies that have come together. They make a metropolitan. The metropolitan come to join a lot of metropolitan. A lot of metropolitan, we said, can go to the nation of a company, of a country. So different metropolitans will be linked together and will come to give us this big wide area network. So that's the one. So we can get to have that and we have access to that. So that's the biggest uh, area network. So we come to see this is the example of a wide area network. So we have something in London, something in America and India, and this information will be able to be tapped and shared. Let's not forget the purpose of this connection that we are having is for exchange of information. Let's not be forgetful of one other point is that whatever you access on the computer, be it you're on WhatsApp, be it wherever you are, whatever information, whatever thing that you're able to access, it's coming from someone else's computer. They are not staying in the sky just on their own. No, 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 no. There is a certain computer somewhere. There is a cloud-based computer. There are servers. There are different systems. There are mainframes and different computers in the system. So you are linking or tapping into that computer by virtue of logging in. Some of them will need you, if it is Facebook, will need you to put in your password. So you go to their computer, it gives you an account, it's like a bank account. It asks you what is your password to get access to this account. Then you can have the information that is there. You stored your pictures, you stored your what. Do you want to access money from other banks to send to your account? Pictures will come and be able to tap in through and out in the principle of networking. Okay, so we come to what we call a personal area network. So in the personal area network, in here we come to see it's something that is simple. It's the simplest communication that an individual can get to have. That's what we call a personal area network. So, e.g., you are seated in your room, you have a computer, you have a phone, you have your earphones, you're playing music. You are able to get information from your PC to your phone. You're able to play music from the computer through your headsets. Because what you come to see is there are different information is being sent in those different formats that we mentioned. So there's a duplex, there's a simplex, and we get to have also the full duplex. So there's a half full and simplex. So information is being sent. Because data is being sent and more than one node is being connected for data exchange sake, we are being connected. So that's a personal area network. And we see that it was within something like 10 meters radius, you are able to have that information shared. So you have personal computers and you can be able to share and do multiple things that you want on that personal area network. So you have your phone, you have your desktop, you have a PC, you have a printer, there's a mouse. So those different segments, information is being sent just like that. Now we move away from uh, those options that we talked about, the different types of network. We have talked about we have the LAN, local area network. We've said the LAN is an office or small building. We talked of the metropolitan. Metropolitan, we mentioned that it's a connection of small lands and it can run to a full company capacity. We've moved from the metropolitan, we've jumped now to the wide area network. The wide area network, we said it's the largest. It can go between continents to continent and communication can be enabled. And we come to talk of the personal network. Personal network is someone who's locked in a room and can share information between the PC, computer, headsets, and be able to print out information. So basically, it's the smallest network type possible. Now we come to topology. So topology defines the structure of the network, how all components are connected to each other. Mind we say two computers can be connected together. So two or more computers, basically a network will have a minimum of two computers. So two or more computers can be connected together. And we can make the LAN, we can make what. But we are saying, how are these cable laying going to be connected from one to the next, to the third, to the fourth? So this is what we call topology. So we come to see that there are two types of topology. There's a physical topology and the logical topology. Now, physical is a geometrical representation of all nodes in the network. Let's look at it. So these are different types of whatever you're saying that is secular. They are nodes, they are computers, they are end devices. They are some might be routers, might be what. So what you can get to see is those nodes are being connected. There is what we call a star topology. So computers are connected in a star. About those computers in the round, they have been connected and to a central switch. They are connected to each other minus a switch in a peer-to-peer connection, something that we call peer-to-peer, one computer to the next, to the next, to the next. There is no intermediate device connected to. This is what we call a mesh, where each device is connected to the other. This is what we call a bus, where there is one terminal, central terminal, where all the other computers are connected to directly or through a cable. Then we have what we call a tree, and we have what we call an hybrid. So an hybrid will be a mixture of all of these that we have talked about. So information is able to flow. If someone has done wiring, maybe cables, they have run cables for internet in any place, they have used one of these methods that we are talking about here. They have used either a star, a ring, a mesh, a bus, and a tree. And each has advantages and disadvantages that come about with such type of a connection. Some will give you more advantage, some will be more costly, some will be what. So it's quite important to understand this because that is how computers are going to be connected and how you're going to understand what is needed. So there's this bus, the one that is down, where there's one central terminal. Let's look at it. So the bus topology is designed in such a way that all stations are connected through a single cable line, which is known as the backbone cable. So there's one line, long cable, where all these are coming to connect. Now each node is either connected to the backbone, that's direct to the line, or it's direct connected to the backbone cable, or a drop cable. There's a drop cable that is coming to the main or just within the lane. And when a node wants to send a message over the network, it puts a message over the network. So when it sends, it doesn't send to another computer node. It throws into this backbone cable. Once it throws into this backbone cable, then all stations in the network will be able to receive whether it has been addressed or not. Unfortunately, so the information will get to reach whether it wants it or not. So the bus terminology is topology is mainly used in that type of internet and that standard. We'll come and talk about those. And configuration of bus is quite simpler as compared to the other topologies. So what are the advantages? It's cost effective, less cable is required, small amounts of networks, and it is easy to understand, easy to expand. Unfortunately, the cable fails. When the cable cuts, the whole network fails. If network traffic is heavy, nodes are more, the performance will decreases. And it's limited to expansion. You can't keep expanding further. Cables have to have limited length. So that's the unfortunate of pass. It will allow all information to move from one area to the other. So it actually uses hubs, a hub to connect and allow that information. So we have what we call a ring topology. It's like a bus, but with connected ends. So they are each connected. One computer is connected to two different sided computers. So the node that receives the message from the previous computer will transmit it to the next. So it's like one computer sends to the other. We call it peer to peer. There is no intermediate route or anything. Information is just moving from one end to the other, one end to the other. So the data flows in a single loop continuous known as endless loop. So one it's an endless loop because information will flow through one computer to the next to the next. It has no termination ends. And the data ring deploys is flows in the clockwise direction. So we have to keep that in mind. It actually flows in the clockwise direction. Now, the advantages of such type is, e.g., one cable is cut, uh, fault devices can be removed from the network without bringing the network down. Because if one computer is one, we cut one cable, at least there'll be connection through the other cables. We'll be still communicating. Uh, so we come to see on the cost side, reliability, but on the disadvantage side, it's difficult for troubleshooting because you have to run through different computers to get to understand where the actual breakdown had happened. And it will give you some delays and the configuration will be difficult because of the slow network. It's actually slow. So that is about that. Then what we come to the start topology where there is a simple single component in the middle when there are computers that are on the side. So each is connected to the other through a middle device. So start topology is an arrangement of a network in which every node is connected to the central hub, a switch or a central computer, a server, so to say a server. So the switch is in the middle, all computers are connected to it. So a central computer is known as a server, where peripheral devices attached to the central are known as clients. So all these are clients, the server is in the middle. So the server will receive and resend to whoever wants that information so they can all access. You jump information. Sometimes this is good when you create it in a company or in an institution. Why you create one computer as a server, you give it good capacity, probably 20 terabytes of data. You give it what so that whoever wants to keep information can be saved there. So that whatever computer each individual is using is just a client. What happened, the goodness with that is, should someone, what you're doing is you're creating a Facebook. So whoever is using an independent computer, they have data. All they'll be doing is logging in through their computer, through the server. They'll log in and have access to certain information. Once they have information, movies, videos, files shared, whatever they want. After they are done using them, they close the computer, the information remains there. They can just copy through or just read through what is there and edit. So this computer dies, whatever happens, the server remains with information. So it's more like a backup system that keeps the information kept. So coaxial cables, these cables that we use for TV from the dish coming down with a central cable in the middle, and RJ45 cables are used to terminate or connect computers. And SAT topology is the most popular topology network implementation. You come to see most of the people have utilized this knowingly or unknowingly in their companies. Advantage of a SAT topology is efficient. There's efficiency, one, there's limited failure because each computer is linking to the what is in the central and easily expandable. You can easily expand. You can just add another switch in the line. If that switch is smaller, you can just keep adding a number of switches with 24, 64 ports, and you have more of that. Now, the disadvantage is the central point of failure. If the middle device that is in the middle dies, then you have a problem, a quick problem. So it needs to be worked around. So this is how sometimes you get to notice when you are working in networking or you work through networking, you come to see that some central devices or some certain devices, once they're affected, everything goes down. So sometimes what we do is we try to use mesh. We try to use mesh, we try to use the hybrid so that there is another line of connection that is given to that. Do not create a loop. I'll come and use those terms later on. Uh, but what you get to do is once this line falls, the other one picks up and communication keeps going because information is always known. When one device is sending, it will be sending, the other one will be receiving, and information will flow just as it's supposed to be done. So people resort to different options to get what want to use in their network setups, network configuration, network runs of the cables, and at the end of the day, the system gets to be made accordingly to how much they are able to spend and what they want to come up with. So tree topology combines the characteristics of bus topology and star topology. A tree topology is a type of a structure in which all computers are connected with each other in a kind of an hierarchical fashion. So the topmost node is the tree topology is known as a root node, and all other nodes are the descendants of a root node. It's basically it allows the fusion of different categories to get to be embedded in one, and data can be sent. So it supports broadband, is expandable, is manageable, error detection can allow you, but it's difficult to troubleshoot because of multiple devices that are connected. Come to the mesh. Mestopod is an arrangement of a network in which computers are interconnected with each other through various redundant connections. So I'll just go back to the picture. where we made the mesh. So the mesh, as it can be seen there, that's a kind of a special type of a connection. It's a more safer one actually. Despite that the star will be faster, the ring will be a bit useless. Uh, the mesh becomes the best because each computer is connected to the other computers or the network devices. Each computer is connected to the network device. So what happens is if one cable dies or anything dies, the network still runs without any interruption from any end. No, this side is not end, this side. There will be no such because all the other ends will get to have capacity or be facilitated with internet because they're still connected. That's the goodness with mesh. Many people like going for it because it allows uh, good connectivity. And so we see the advantages. It's reliable. The mesh support networks are very reliable, as if any link breakdown will not affect the communication between the connected computers. And they are fast communication actually. It's very fast between the nodes. Easier configuration. It's just adding one device to the other. It's just the disadvantage side is on the downside. It's costs too expensive to run too many cables. It's very difficult to maintain sometimes because there are a lot of cables that are running, and the efficiency aspect is kind of reduces because of too many run-up cables. And when we talk of the hybrid now is a combination of various types of topology. So you find that there's mesh, there is star, there is bus, different one. So it will just run. It will run just like that. So this is where actually brings us to an end for lecture. So what we have come to understand first and foremost, to come to see that a computer is a network. A network is a communication between different computers that are connected. So a minimum can only be two, and for the purpose of sharing information or nodes. And we come to see that there has to be most important thing has to happen. One has to be the receiver, the other one has to be the sender. It can be the same, but at a certain point when that information is supposed to be shared, one has to be the receiver, the other one has to be the sender. There has to be a message that has to be sent. There has to be a channel through this message will get to be sent. So these and protocols, there has to be rules that has to be agreed upon for this information to go. Because you could be sending something that is not understood by the other. But this, how is that information going to flow? So this is what we need to come to understand about information flow. And we've come to learn different types of networks, different types of networks. We learned there is LAN, there is network, there is PAN. We talked of wide area network. We talked of metropolitan area network. We talked of personal area network and local area network. So we saw how they move from a PAN to a LAN to MAN to WAN as continental interconnection is allowed. Then we talked of the topology, how this cabling is going to be done, how the connectivity is going to be done. So in that topology, we've talked about different ones. We talked of a bus, we talked about the ring, we've talked about the star, we've talked about the mesh, we've talked about the tree, we've talked about the hybrid. And we said that a technician who is running around to run cables can pick any of the methods provided with the material they are given and to what extent they want to be disturbed so they can get to use any of those. So we end here.